Good morning, good afternoon, and good evening, everyone. I'm Chloe Bianca Anchoa from SBCS1B. Today, I'm here to introduce you to Java programming. By the end of this lesson, we should be able to discuss and describe the Java story, including how it started and evolved, identify Java's technology features and requirements, and finally differentiate between a Java applet and a Java application. First, the question. Let's answer the question, what is Java? Java is a high-level, general-purpose, memory-safe, object-oriented programming language. It is intended to let programmers write once, run anywhere, meaning that compiled Java code can run on all platforms that support Java without the need to recompile. Java applications are typically compared to bytecode that can run on any Java virtual machine, or JVM for short. Regardless of the underlying computer architecture, the syntax of Java is similar to C and C++, but has fewer low-level facilities than either of them. The Java runtime provides dynamic capabilities such as reflection and runtime code modification that are typically not available in traditional compiled languages. Java was created in 1991 by James Gosling, Mike Sheridan, and Patrick Norton from Sun Microsystems. Originally, they wanted to create a programming language that could run on any kind of device, from household electronics to computers, without needing to rewrite the code for every machine. This is what led to Java's biggest strength, being platform independent. At first, Java wasn't even called Java. It was originally named GreenTalk, with the file extension .gt. Later, the team renamed it Oak as part of the Green project. However, there was already another programming language named Oak, so they changed the name again, this time to Java. But why Java? Why is the programming language named Java? Well, according to James Gosling, Java was one of the top choices along with Silk. Java was so unique that most of the team members prefer Java than other names. Java is an island in Indonesia where first coffee was produced, called Java Coffee. The final name was inspired by the developers' coffee drinking habits, so they took the name from that. In 1995, the Time magazine even listed Java as one of the best products that year. A year later, in January 23, 1996, the first version of Java was released, JDK version 1.0. Marking the official beginning of Java programming. Since its release, Java has gone through many versions and improvements. It started with JDK Alpha and Beta in 1995, then JDK version 1.0 in 1996, JDK version 1.1 in 1997, J2 SE in 1.2 in 1998, and continued improving over time, adding new features, libraries, and tools. The latest versions like Java SE 9 and 10 introduce faster performance and faster developer tools, showing that Java continues to evolve even decades after its creation. The very first project using Java was called Star 7. It was a handheld remote control device, and it was created as a part of the Green project. The Green project refers to the initial development phase of what later became the Java programming language. Java was originally made for embedded systems and not just computers, meaning it was designed to work across different electronic devices. Now, what is Java technology? Java technology is more than just a language. It's an entire platform made up of 4 parts: a programming language for writing code, a development environment for building applications, an application environment for running programs, and a development environment for distributing them. Java has many important features, make it one of the most popular programming languages in the world. Let's take a look at each of them. The first Java feature is Java is object-oriented. This means that everything in Java is treated as an object, something that contains both data and actions. This feature makes Java easier to use, maintain, and organize. The second Java feature is simple. Java is simple because its syntax is easy to learn. especially if we already know C or C++. However, Java removed many confusing or error-prone features from C and C++, such as pointers and multiple inheritance, making it safer and easier for beginners. The third feature is secure. Java is a secure language. It has no explicit pointers and it runs programs inside a sandbox environment, meaning programs can't harm the system they're running on. It also includes bytecode verification, which checks codes before running it, making Java a great choice for safe web and enterprise applications. Fourth feature is platform independent. Java is a platform independent, which means you can write once, run anywhere. Once you compile a Java program, it produces something called bytecode. This bytecode can run on any device with a Java Virtual Machine or JVM, regardless of the operating system. Feature number 5. Java is robust, meaning it's strong and reliable. It has automatic memory management, error handling, and strict type checking, which all help reduce program crashes and runtime errors. In short, Java helps developers write safer and more stable programs. Feature number 6. Portable. Java is portable. The compiled code or bytecode can run on any system without modification. This is what allows developers to build programs that can work across devices, from desktops to mobile phones. Feature number 7. Architecture neutral. Java is architecture neutral. It doesn't depend on any specific computer architecture or hardware. Because Java uses bytecode and runs inside the JVM, it works the same way on all systems. That's why Java is commonly used for cross-platform software. Dynamic. Java is dynamic. It can load new classes and link them at runtime. This means that Java programs can adapt to new conditions or add new functionality while running, making it flexible for modern applications. Interpreted. Java is interpreted. After you compile your source code, the bytecode is interpreted by the Java Virtual Machine line by line at runtime. This is what allows Java to run on multiple platforms. High performance. Although Java isn't as fast as C or C++, it's still high performance because of its just-in-time or JIT compiler. The JIT compiler converts frequently used bytecode into native machine code, while the program runs, speeding up execution. Multi-threaded. Java supports multi-threading, meaning the multiple tasks or processes can run at the same time. This makes Java programs faster, more efficient, and ideal for complex applications like games, chat apps, and servers. Distributed. Finally, Java is distributed. It supports distributed computing through technologies like RMI, which is remote method invocation, and sockets. This allows programs to communicate and share data across a network or even the internet. Now let's move on to the Java development environment. When you install the Java Development Kit or JDK, your computer gets several folders containing important files. One example is the bin folder, which has executable files such as javac.exe, the compiler used to turn your source code into bitcode. Together, the JDK, the compiler, and the JVM make up the Java development environment, the full set of tools needed to write, compile, and run your Java programs. Now, here's how a Java program works. First, you write your code in a text editor and save it as a Java file. Then, the compiler converts it into bitcode and stores it as a class file. Finally, the JVM interprets the bitcode and executes it. That's simple. This image shows how a simple Java program is written, compiled, and executed, also known as a Java program cycle. At the top, we can see the Java source code is a short program called Hello QCU, which prints the message Hello QCU on the screen. Next, the code is passed out to the Java compiler, and the compiler checks the program for errors and converts the human-readable code into bitcode. After compilation, the Java Virtual Machine, or JVM, reads the bitcode and translates it into machine language, which the computer can actually execute. Finally, the output appears on the computer screen, showing the text, "Hello QCU." So in short, this image summarizes the complete Java program cycle. We will first write the code, then compile it, then run it on the JVM, then it displays the output. In this slide, we show the two types of Java programs. First, we have the applets, and these are small Java programs that are meant to run inside a web browser. In the early days of the internet, applets were used to add interactive features to web pages like animations or calculators. Next, we have applications, which are standalone programs. These don't need a browser to run. Instead, you open them directly on your computer just like any normal desktop software. Nowadays, applets are rarely used because browsers no longer support them, but applications remain the main way we use Java, especially for software, mobile apps, and enterprise systems. Every Java program follows a clear structure. A program is made up of classes, and each class contains one or more methods. Inside each method are program statements. These are instructions the computer executes. More importantly, every Java program must have a main method. This is the entry point where the program starts running. Without it, your code won't execute. Think of it like this. The class is the container, the method is the task inside it, and the statements are step-by-step instructions of the task. When you run a Java program, the JVM loads the class and runs the main method. This method must be declared as public, static, and void. Each part has a purpose. Public means the method can be accessed by the JVM. Static means it belongs to the class itself, not an object. Void means it doesn't return any value. You can have many classes in one source file, but only one of them can be public, and that public class must have the same name as your file. In Java, your application files are usually organized inside folders, or what we call a directory structure. You'll have two main kinds of files: the source file with the Java extension which contains your code, and the class file with the class extension which contains the compiled bitcode. When the compiler sees that your code refers to another class, it searches your directories for the matching class file. This system helps keep large Java projects organized and easy to manage. When you run your program, the interpreter, or the JVM, searches for class files to execute. Both the compiler and the interpreter use something called classpath variable to find these files. Think of the classpath like a roadmap that tells Java where to look for your class files. If a file isn't in the class path, Java won't be able to find it, and you'll get a class not found error. In Java, source code is a human-readable set of instructions, written by a programmer that defines how a program should behave. Source code files are saved with the Java extension. After writing the code, it's compiled into bitcode in a class file, which is then executed by the JVM. Here's a sample of a Java program. When we run this, the program displays the text "Hello World" on the screen. In Java, we often group related classes into packages, which are like folders that organize your code. For example, if there's a class called student inside a package called course, the class's qualified name is written as course student. That means the file is stored inside a folder called course. The full path to it would be course/student.java. If you want to use that class in another program, we can import it using the command import course.student:. This naming system helps Java locate and manage code efficiently. Using packages and proper naming is very important in Java. First, it makes it easier to find and reuse your classes because everything is organized clearly. Second, it avoids naming conflicts, meaning two classes can have the same name if they're in different packages. Packages help with access control, allowing you to decide which parts of your code can be used by others and which parts should stay private. So, packages don't just organize your files, they also help maintain security and prevent confusion. This diagram shows the compilation flow in Java, or simply how a Java program runs. It starts when we write our source code and save it as a Java file. Next, the compiler translates that code into bitcode, stored in a class file. Finally, a Java virtual machine, or JVM, reads and executes that bitcode, producing the program's output. So the process is write, compile, execute, and output. This flow explains why Java is called platform independent, because the bitcode can run on any device that has a JVM installed. And that concludes our presentation for CC102, Introduction to Java Programming. We've covered Java's history, key features, basics of how Java programs are written, compiled, and executed. Thank you for listening. Have a great day.